Hello, my name is Natalia Rodriguez. I'm here to talk about the International System of Units and Measurements, also known as the metric system. The metric system has its origin in the French Revolution, where the ideals of fraternity, equality, and liberty were moving the society away from old customs and traditions. This, together with the current of the Enlightenment, where science knowledge was not to be achieved through logical conclusions that came from very old civilizations, rather, we were to sort our own conclusions through experiments and a system that would allow others to confirm or deny. As the French people wanted to get away from old traditions, a new system was proposed, metric system, one that we use today. Originally, its units were defined by things we can actually measure, and by natural things through the lenses of the Parisian people. These units, as useful as they are now, were not well received, and since the French society had a lot of pressing issues such as the coming monarchy and a second revolution, the idea of adapting a new system was pushed away. So it took around 100 years until the metric system was finally put into use once the Industrial Revolution came to be. Since the new coming age of technology, people were required to manage, ensemble, and operate new technologies and machines, the need for more specific and precise systems of units was really present. So the metric system came into view as something that was already made, only needed to adapt. Thanks to the Industrial Revolution, the metric system was most widely known as something together with machines and technology, and was widespread in different countries. Since more and more cities were industrialized, the usage of the metric system was more and more common in everyday activities. Many people now using the metric system. It wasn't until 1875 that the International Bureau of Weights and Measurements was established in France. And this is the institute in charge of overviewing the correct usage of the metric system, but also of the correct definitions of each unit. It wasn't until 1921 where different states declared the metric system as their official unit system. The science we know today can only be achieved through a general understanding of two basic principles. The fact that we can doubt all ideas as long as we cannot confirm them, and the independent results that we can gather. What this means is that knowledge and ideas can only be obtained if different sources came to the same conclusion. This system proposed in the Enlightenment required a measurement system that would be universally known and could be understood. The scientific community decided that this would be the one they officially use for publications and experiments. In 2016, it was agreed upon that all units in the SI would be redefined using universal constants. The project came along nicely, though most scientists came crashing into a wall when they realized that the kilogram could not be defined as it was only based around a cylinder. And in 2019, Planck's constant was finally written down with an acceptable amount of uncertainty, allowing us to redefine the kilogram, the ampere, and the mole. Using an international system has many advantages, especially for the scientific community, as it reduces uncertainty in conversion and allow different people to understand methods of an experiment. This means is that the process of peer reviewing was facilitated. Ecuador is also a country that uses the international system. It was declared the official unit system in 1974, but it was previously used in common day activities. The institute in charge of overviewing the correct usage and measurement of these units is the Instituto Colombiano de Normalización. Internationally speaking, the SI units are considered as. However, there are 3 countries that do not use the international system as their official unit system. These are the United States of America, Burma, and Liberia. What this means is that their contracts, business, and science are not required to use SI systems within the country, but as the international standards hold, they are required to use them when dealing with contracts and publications. This can be a rather jeopardizing condition. For example, there was a crash in the Mars orbiter in 1999, where the NASA scientists designed and calculated the orbiter using SI units, but due to a process of manufacture, the engineers used the English system. They failed to convert the force in the Mars climate orbiter crash into the planet and costing around $25 million in damage. In oceanography, we also use the International Unit System. It was published and confirmed in a guideline given by UNESCO to the marine researchers in 1985, where it was established that the international systems units were to be used, also that the unit for salinity would be PSU, which is Practical Salinity Unit. Having an international system of units is really useful for humanity as a whole. It allows us to communicate and reduce misunderstandings, especially in science, where independent results are key to scientific knowledge. Also, failing to adapt to a new system can be harmful in a lot of different ways to very different people in social circles, and can also be costly in the long run. Even so, the cost of adapting a whole country to a new system is rather low than the cost of failures such as the Mars Climate Orbiter. Thanks for listening.